by and large, we say when it's carbon containing, and that has carbon and hydrogen bonds, then it's organic, meaning living, and inorganic
Comes from
doesn't
life.
contain those. So, but interestingly enough, if you go back far enough into the 1800s, there was this movement that was called vitalism, and it was kind of adopted or whatnot for quite a period before it was thrown into the bin. But it suggested that organic materials, or anything that requires an organism to create that substance. And so you have urea, for instance, which under those definitions was considered organic because it came through urine, for instance. Urea was a natural substance. But under those definitions, as soon as you take urea and you manufacture nitrogen through the Haber-Bosch process or something synthetic, now all of a sudden, now it's not organic. But let's not forget, urea still contains carbon. And so what do we do about that, organic versus inorganic? And I like the vitalism aspect because I really think it encapsulates what we're doing. Yeah, sure, there are times we're taking a synthetic source of nitrogen and we're complexing it, or even you can do that with trace elements simply through zero-ionic compounds, positive, negative charges like amino acids, humic acids, that will actually kind of form these superstructures and keep them encapsulated until used by living organisms. But then there's a whole other realm, which is where we use microbes themselves to actually synthesize, to use these ingredients, these synthetic raw ingredients, and through fermentation and digesting, they now convert inorganic ingredients into organic compounds, volatile acids and phenolics and these other things. And I really believe there's miles to go in research in this field, but that's something we've done quite a bit, is utilizing fermented sources of inputs that through a fermentation process are now become very much an organic compound. They may or may not have started out that way, but they're a building up. It's a reduction. And so, and we see that the difference between compost and ferments. Composts are highly oxidative and low energy, very stable, but ferments are the opposite. They go through a reducing process where hydrogen ions are added and small things become bigger, whereas in compost, big things become small. And again, I'm not saying, oh, then this is better than compost. I'm saying they're two different tools and we can utilize them differently. But through microbial processes, through microbial metabolites, as it ferments, these things excrete what we know are PGRs and food for plants. But also we also know too, some of these microbial metabolites actually will increase the rate at which microbes divide. Whether that's through quorum sensing, I'm not sure. All that to say, when we can step back a bit and look at things principally and say, what are we really after here? We're really after trying to supply the best source materials at the best cost so that we can get the best results and we can actually build soil and appreciate soil.